Okay, using the demand function from question 2, here it is, and the cost function, here it is, they ask for what is the profit. Okay, the idea that holds this question together is that profit is revenue, how much money comes in, minus costs, money that goes out. This is going, filling in the blanks in this is how we're going to get this problem done. So we have our cost function, it's all this. We don't have the revenue function, but we pretty much do. The revenue function is our demand here times X, because it's revenue is the number of things you sell, which is X, multiplied by the price you get for each of those things. So the revenue is 6x minus 0.008x squared. That is our revenue function. And now we're ready to write profit equals revenue minus costs. The profit is going to be, I'm going to keep writing out profit because I don't want it to get confused with this price function up here. The profit is your revenue, which we found is 6x minus 0.008x squared, minus, and the cost function is all this, 55 plus etc. 0.3 zeros, 4 zeros, 1, 2, 3, 4, 8x cubed. So, if we collect terms in that to make it look a little nicer, this negative sign applies to everything inside these brackets. We get minus 0.408x cubed. Takes care of that. We have minus 8 thousandths x squared plus 9 thousandths x squared makes positive 1 thousandth x squared. For x's, we have 6x minus 1.9x. That should be 4.1x. And then we have minus 55. So this is our profit function. Now, how many items must be produced to maximize profit? You remember the way we find this was we look for something called the marginal profit, which is d profit dx. It's the derivative. And from that, we're going to find if your marginal profit is positive, that's telling you you'd make more money if you produced more stuff. That means your profit's curving upwards. A negative marginal profit means we're going to lose money if you make more stuff. That means you're on a downslope like this, where it isn't worth it to make anything more. And if marginal profit is exactly 0, it means you're right at the top of the hill. You're at the best possible spot where this curve is flat. And what that means mathematically is that the marginal profit, this derivative we're about to do, equals 0. So when we do this derivative, we get 3 times this thing minus 0.00024x squared, and then 2 times this, 0.002x, and the derivative of 4.1x is just 4.1. All that has to come out to 0. Well, it's a quadratic, so you know what's going to happen. Okay, one of the things that could happen is you could graph this on a calculator and then use a maximum finding function to see where the peak of it is, or sorry, where its 0 is, sorry, not maximum. But because we're hardcore, let's do it with the quadratic formula. X is minus b plus or minus root b squared minus 4 times a times c all over 2 times comes the calculator. 0.002 squared. Those minuses cancel, so I'm putting plus 4 times 0.00024 times 4.1. So in the radicand I get, okay, outside the radicand I have 0.002 plus or minus. In the radicand I have 0.00394, and the square root of that is 0.06277. And that's all over minus 0.00048. I just did 2 times the number in the brackets. So if we add here, we're going to get a positive number in the numerator divided by this. It's going to come out negative, which will be telling us to produce negative amounts of stuff. That's not reasonable, so I'll skip that answer and go straight to the minus one. Minus 0.002 minus 0.06277. And then we divide that by negative 0.00048. And I get an x of 134.93, but I'm just going to round it to 135. So this company's most efficient way to bring in money would be to make 135 of whatever their product is.